Hi students, in this video we are going to see about structure of atom. So the previous chapter deals with atom and molecules. So this chapter deals with structure of atom. So initially there were different different scientists, they explain about how the atom will look like, fine, and finally we follow say atom will be in the spherical and nucleus will be at the center and it is related with the solar model. Yes, so we are going to see one by one. So what is an atom? Atom is the smallest particle and everything in and around is made up of atoms, right? Everything is made up of atom. Say book, pencil, chair, bag, everything, okay, in and around whatever you use, everything is made up of atoms. So atom is the smallest particle. So now different scientist views we are going to see. Okay, the first scientist which I am going to explain about is Dalton, John Dalton. So Dalton, he explains that atom cannot, it's the smallest particle and it cannot be divided. And Dalton said that atom consists of subatomic particles, electrons, protons and neutrons. So Dalton explained that atom is the smallest tiny particle or smallest particle which consists of subatomic particle, that is electron, protons and neutrons. And what he said is atom cannot be divided. And next what he said is when two similar atoms combine, to form a molecule, to form a compound. So the atoms which is of similar type will have a similar properties. For example, I will take example. Okay. So when hydrogen atom, okay, combine with another hydrogen atom, so it forms hydrogen molecule, right? Now what about the hydrogen molecule? Will it have the similar properties or different properties? So it will have similar properties because both are same atoms. Whenever both atoms, same atoms combine, it forms a molecule, right? And it will have the same properties of atoms combining. And what did he say next? When hydrogen reacts with oxygen, it forms water. I didn't balance it, okay? I am just explaining you that when hydrogen reacts with oxygen, it forms water. Now what do you know about hydrogen? It's the lightest, lightest gas, yes. And then it is highly inflammable, means it easily catches fire. And what about the oxygen? Oxygen is the supporter of combustion. If the oxygen is not there, nothing will burn, right? For example, if I take a candle, I am going to light the candle and I am going to close it with a tumbler, glass, okay? Now what will happen? Immediately the fire will put off because no oxygen there. So oxygen is a supporter of combustion. If the oxygen is not there, then the combustion will never happen. Nothing can burn without oxygen. And then come to water. What is the property of water? Water helps in putting off the fire, correct? Will the water supports combustion or not? It will never, right? Water is used to put off the fire, correct? So when hydrogen reacts with oxygen, it forms water. So what do you understand from this? Water consists of hydrogen and oxygen, but in a compound, elements will lose its identity. Am I right? So there is no property of hydrogen or oxygen shown here, but water is having different properties. Am I right? It has a different properties. So what do you understand from this? When two similar atoms combine to form a molecule which will have same properties, whereas when two different atoms combine, it forms a compound where it has a different properties of the elements, not the same property. Am I right? Understood? Yes. So this was Dalton's theory, but he gave one drawback. Okay, what's the drawback of his theory is he said neutrons will not involve in the chemical reaction. Most of the chemical reactions, any type of reactions, okay, happens around you will be involving electrons. Okay, it involves electrons, but only few reactions involves neutrons. So that is example atom bomb, na? A hydrogen bomb or atom bomb. So all this will have neutrons getting reacted. Okay, so but Dalton said that neutron will never take part in the reaction. So that was the drawback, right? So now we are going to see the next theory. Okay. J.J. Thomson, okay. So Thomson, he gave one theory. What is his theory is, his theory, simple example let us take, watermelon. So you know how the watermelon will look like, right? So according to J.J. Thomson, what he explained is, if you take a watermelon, okay, this fruit part is considered to be protons. Fruit part is considered to be protons and seeds are considered to be electrons. So so he also connected this with Goa. He also connected it with plum and pudding cake, plum pudding cake. So where you see you have a lot of cherries, nuts and all. So whatever, now let us take the watermelon for better understanding. So according to J.J. Thomson, sea of protons, what do you mean by sea? S-C-A-C. Sea of protons, ocean of protons means, what is the meaning of that? More protons are there. And seeds, I mean the electrons are embedded like seeds of the watermelon. So what is the meaning of that? So seeds, if you take a watermelon, seeds will be less only, compared to the fruit part, the seeds will be lesser, right? So what he is trying to say, the more protons will be there and less electrons will be there. So do you think that it's right? Do you think that protons will be more and electrons will be less? Yes? What is your reply? No. Actually, atoms are electrically neutral. What do you mean by that? The electrons and the protons should be equal. Say 10 protons are there means 10 electrons will be there. 100 protons are there means 100 electrons should be there. For any neutral atom, both should be equal. Protons and electrons should be equal. So this is the drawback of J.J. Thomson. Actually, one interesting fact I will tell you. J.J. Thomson only found electron. Okay, he actually divides the name electron. So what do you understand from his theory? He said that the sea of protons where the electrons were embedded like seeds in a watermelon. If you take guava also the same case. If you take a plum pudding also the same case. Where the cherries and plums, whatever the plum present there, it is considered to be the electrons. But actually speaking, he couldn't explain about the stability of an atom, because atom is electrically neutral, means the number of protons and electrons are always equal. Fine. So this was the drawback of J.J. Thomson. Okay. So what do you understand from all this theory? What they are trying to explain is how the atom will be, how the atoms will look like. If you see under powerful electron microscope, so definitely it will consist of the nucleus. The nucleus will be very small, okay, not as you think like big ball kind and all. It is very, very small, okay. So the nucleus will be very small, in which you will have protons and neutrons present inside the nucleus. What about the electrons? Electrons will be continuously revolve. It continuously be revolving around the nucleus in the definite shells. What about the solar system? In a solar system, sun is in the middle, correct? What about the planets? They will be revolving around the sun in the definite orbits. Will they come out of the orbit? No, they don't come, no. Similarly, the nucleus will be there. Inside the nucleus, inside the nucleus, protons and neutrons will be there, and electrons will be revolving around the shell, okay, in the definite orbits. They will be revolving around the nucleus in the definite orbits. They will never come out of that orbit, okay. So we can say that this 80% of atom model is given by Rutherford. Okay, so he only gave 80% of model, like he connected the atom with respect to solar system. Okay, sun is in the middle, similarly atom, nucleus in the middle, planets revolve around the sun in the definite orbit, similarly electrons revolve around the nucleus in the definite shells or orbits. Okay, so this is how they found like how the electrons, where the electrons will be and where the protons will be, right? What is the charge of nucleus? Anyone? What is the charge of nucleus? Positive. How? Because inside the nucleus you have protons and neutrons. So protons are positively charged. Alright, yes. So now like what we are going to see is who found electrons, who found protons and who found neutrons. Then we will finish this video. Okay. The electrons was found by J.J. Thomson. Okay. And what about protons? Protons was found by James Chadwick. James Chadwick. Okay. Protons was found, neutrons was found by Chadwick. Okay. Not the protons, neutrons. And protons was found by Goldstein. Goldstein. Okay, once again I will repeat. Electrons was found by J.J. Thomson, neutrons was found by James Chadwick, protons was found by Goldstein. Okay, any of the competitive exam, they can ask this. Fine. So understood what is atom? Atom consists of nucleus. Inside the nucleus you have protons and neutrons, and electrons revolve around the atom, around the nucleus in the definite orbits or shells. And then we saw like the different views, like how did the Dalton say and what is postulate, what is the drawback. Then we saw what is J.J. Thomson model and what is the drawback of him. And then finally we arrived at like how it is connected with the solar system, right? Understood? Let us have a thorough session with a lot of pictures for you for the better understanding of this topic, right? Thank you, students.